Welcome back to Industrial Problem Solving. My name is Dave Roysum. In the first two short segments, we almost completed our working problem description. What we missed, though, is vital, and that is a tabulation of opportunity costs. It is costs that help us define priorities. It is costs that both motivate us and constrain what we can do. It is costs that define the decision-making process that follows towards the end of this problem-solving process. Waste is a large opportunity cost in many plants, so let's start there. When a machine starts up, it may not settle into equilibrium for a period of minutes to hours, depending on the process. Even though saleable web is made, it might not be as good as a product in the next master roll. In other words, risky for internal rejects and customer complaints alike. Once we do get into the groove, so to speak, most will trim the edges of the web for any number of reasons. The paper industry euphemistically calls trim waste shrinkage. Let's be clear, nothing is shrinking here. It is edge trim waste, pure and simple. Perhaps the most familiar type of waste is internal rejection because a product is out of spec. However, familiar does not always mean well understood or well done. Some specifications simply do not correlate to customer complaint, perhaps because the test method or sampling is not good enough, or perhaps because that property is not something the customer cares much about. Even when the customer does care about a particular property, it may be a visual defect. Visual rejection is subject to a lot of squishy, wiggly interpretation as to how ugly it really is and what the threshold of pain should be. However, the waste that costs more dollars per pound than any other is customer complaints, claims, or returns. For one reason is that you put more time, materials, and energy at the end of the process than waste taken upstream. Another reason is that you add transportation costs to the customer and back from the customer. Another reason is that returns are often the subject of many hidden costs, such as phone calls and meetings and trials, and capital expenditures to try and reduce complaint. The biggest hidden cost, though, is the risk of a customer ditching you for a competitor who does not give them so much grief. In summary, a customer return may cost 2 to 10 times as much as an internal return, and thus customer-producer risks should often be weighed towards internal waste than customer complaint. I know what you are thinking. Tell me something new, Dave. I already know this stuff. Do you? If so, you should be able to list the top 3 causes of waste, delay, and customer complaint, as well as the approximate annual costs of these 9 items. Not your job, you say? Somebody knows about costs, you say? No. It is everyone's job to know about money, because that is what a business is mostly about. Money. Delay, or downtime, is another cost area. Here, the common measures are hours, or efficiency. Yet, the proper measure again is in dollars. While the dollars per hour for a given machine are not as simple as the cost per pound for waste, you would be conservative to assume the value of lost production. The costs of production depend largely on the size and the speed of the machine, as well as the cost of the web. However, a rough estimate is as follows. The smallest rewinder may cost $200 per hour. Many smaller converting machines may cost about $2,000 per hour. Finally, paper and steel may cost $20,000 per hour, which is more than $300 a minute, which is more than $5 per second. Of course, your mileage may vary, as they say, but you get the idea how downtime can be expensive in a hurry. Waste reduction is a complicated discussion that we will get to later in this course. Delay is a little simpler, at least to get started. That is because industrial engineers have developed a wide set of tools for analyzing productivity. Two are given here as examples. The first is to break the state of every cell in the manufacturing process into 4 possible states: run, down, blocked, and starved. These, in turn, can be further subdivided. We discussed several ways to put numbers on these in the Winder productivity module of my Web401 training. Another very useful tool is SMED. This process begins with simple concepts like eliminate unnecessary actions, parallelize all remaining actions, speed up those actions on the critical path, and finally, plan and prepare for when you must go down. A well-known example of this process is changing tires during an auto race pit stop. Here, 4 tires can be changed in 14 seconds, while we would be lucky to get 1 tire changed on our family car in 14 minutes. While SMED begins with common sense, there's enough there to justify going to school for a couple of days on the topic. 5S is another popular but somewhat less rigorous program. There are many myths surrounding the concept of productivity. Perhaps the worst is the idea that speed and productivity are closely related. There are machines and processes for which speeding up will cause increased waste and delay, and thus negate any gains and then some. There are also many machines and web handling limitations that might make speeding up difficulty, prohibitively expensive, and in some cases, physically impossible. It is your job to estimate the opportunity costs of individual areas of waste, delay, and customer complaint. This cost is useful, indeed required, for many types of analysis. The most obvious is that it is needed for cost-benefit or payback calculation that should be part of any capital improvement project. However, there's another reason that's not widely discussed. That is, opportunity cost is an indicator of the urgency and effort that should be applied to a particular problem. Problems that are, for example, $10,000 per year might be worth tackling if you can reduce it by a simple adjustment of something like a setting, provided that the plant has the discipline to maintain that new setting. Larger costs will begin to allow you to spend modest amounts of money, if the payback is there. At still larger levels of opportunity costs, the urge and engineering talent needs to be increased to stop the hemorrhaging before the patient dies due to blood loss. It is everyone's job to know the opportunity costs of individual areas of waste, delay, and customer complaint. Don't assume that just because a boss or a customer says it's important, that it actually is important. The converse might also be true, that hidden costs for many problems might be much larger than the boss might suspect, and thus opportunities are lost. Once you know the individual costs of waste, delay, and customer complaints, you can rank them on a Pareto diagram. However, this oversimplified analysis has many pitfalls. First, it may be that an underlying problem may show up as separate categories and thus underestimate that underlying problem. In that case, the categories would be too fine. However, it is more likely that the categories are too coarse. As my Web 101 students learn, a wrinkle is not a wrinkle is not a wrinkle. This is also true of many winding defects. Here, the tendency is to group things together that don't belong together. While they share similar outcomes, such as poor flatness or cylindricity, the causes and cures may be totally distinct, possibly being on different parts of a machine or even on different machines. Finally, this does not consider cost-benefit. We may find that number one is number one for a darn good reason. It might be difficult or expensive to budge. Still, ranking opportunity costs is a worthwhile place to begin as long as you don't get lazy and stop there. Once a project begins, it develops a life of its own. It is difficult to kill even if and when new evidence comes in that it is not going anywhere. This is particularly true of capital expenditures. No one is going to be brave enough to kill the project once money is approved. Thank you so very much for joining me in this introduction to the problem-solving process. In the next many clips, we will dive into the heart of problem-solving. Here we will share dozens of formal and informal methods to make this process faster and more reliable. Stay tuned.